Hello, my name is Walter Tinsley. I am the author of The Underdog's Guide to the SAT, which there are links to below should you be interested. Today I want to chat with you about the formulas which I think you need to know cold going into the SAT. Or should you know these formulas cold, you will easily outperform anybody who doesn't. Some of you might be thinking that there's no point in memorizing these things since they have formulas at the beginning of the math section. This is partially true. They do have those formulas, but they don't have all of them. And I'm going to ask you, who's going to do better on the test? The person who has to look it up every time, or the person who knows it cold? I hope you agree with me that the latter camp has a significant advantage over the former. So with that, let's see what we can do here. This is just an intro card. Let's see here. So let's start off in a very basic manner. Do you know the Pythagorean theorem? I hope that you do. And do you know the first three Pythagorean triples? This is a little bit more rare, but it's something you should know. So the first situation is, do you know the Pythagorean theorem? And that would be a squared plus b squared is equal to c squared. Obviously, a and b being interchangeable in this situation. The next thing to know is that there are three very commonly used Pythagorean triples, and you just have to have these memorized going into the test. The first one is 3, 4, 5. The second one is 6, 8, 10. That's a little bit of a math joke. It's not a unique triple. It's just 3, 4, 5, which has been doubled. I put it in here because it is very, very commonly used. And the last one is a unique triple. It is 5, 12, 13. These are the big three, with these first two being the most commonly used, and this third one being kind of a distant third. But anyhow, so 3, 4, 5, 6, 8, 10, and 5, 12, 13. Let's keep on moving. Next, you need to know the properties of 45, 45, 90 triangles, particularly their proportions. And those proportions are a, and a square root of 2. You might have heard this or remember this from geometry class, but this is very, very relevant and can save your bacon on the SAT. The first one to know is this, or the application is typically this. You'll get a triangle and know somehow that it's 45, 45, 90, and then you'll see that this is 10 rad 2. You'll need to know that these are 10 and 10 very quickly in order to get area or perimeter or some other output. So please remember, a square root of 2 is going to work to a 45, 45, 90. And again, that can just save your bacon in the right situation. Next up is the 30, 60, 90 triangle. These are exactly the sort of things you need to know. So the proportions are 2a, and then a square root of 3. This is relevant because we often get some sort of indication and then one or more of these data points and need to know the other ones very quickly. And this can really save you a lot of time if you have these memorized, because obviously you don't have to Pythagorean anything out. So 30, 60, 90, a rad 3, 2a. Some students get these confused. They're not sure which one to put where. One way of remembering that is that a hypotenuse is always longest on a triangle, and 2a is larger than a rad 3, which is just 8 times the square root of 3, which is about 1.7, or the square root of 3 is about 1.7. So if you want to put some real numbers on that, if you make a equal to 10, this is obviously just 20, and then this is just 10 times the square root of 3, or about 17. So again, hypotenuse is always longest. One way of remembering these against 45, 45, 90s is that 45, 45, 90s, let me get back to that screen, have two different types of sides and two different types of angles, and it is a square root of 2. 30, 60, 90s have three different types of sides and three different types of angles, and it's a square root of 3 is kind of the funny one to deal with there. Moving right along, you need to know the area of a triangle. Do you know the area of a triangle? Or how to get the area of a triangle? That's very important. And do you know where the height of a scaling triangle is? Let's talk about both of these. The area of a triangle, the formula for the area of a triangle, is always base times height divided by 2. Now, some people want to say 1/2 base times height. That is also correct. You are free and welcome to use that. You will never go wrong doing such a thing. I just personally think base times height divided by 2 is a little bit more clean, so it's the one I use. But potato, potato. The next thing to know is, if this is your base, where is the height on this triangle? Well, you kind of have to draw it out. this is going to be your height right here. It's always at 90 degrees. Now, some people want to draw it here. That's fine. Bring it over. That's the same thing. That's height, if I could make a straight line there. Some people need to be really fancy and come out here. That's fine too. All three of these are heights. As long as, you know, you go to the same point, you're fine. If you're in a pinch, you can flip the triangle over, pick another base, and then height would be in 90 degrees. It's a little bit easier to see in this one. So that's that. Let's move on. Ah yes, how many degrees are there in a triangle, rectangle, and pentagon? These are kind of the three to know, and then I'll give you a formula for the rest. The first one is there are 180 degrees inside of a triangle, 360 degrees inside of a rectangle, and 540 degrees inside of a pentagon. Should you have some sort of exotic or weird shape beyond that, the expression I would recommend you use is this, n minus 2 all times 180. And so if you have a 100-sided shape, that'll really help you out. You know, and so that would be 100 minus 2 all times 180, which is big. 17,990. No, I don't know. It's big. It's under 18,000. But anyhow, let me see if I can prove this to you. So a triangle has three sides, 1, 2, 3, and 3 minus 2 is 1. 1 times 180 is 180. For a four-sided shape, the sides don't have to be equal or match up. In fact, let me preview some higher-level stuff here. If they want to get weird on the SAT with the four-sided shape, they'll use this one. So if you can imagine all these as straight lines, this has 1, 2, 3, 4 sides, and therefore is four-sided shape, and therefore has 360 internal degrees. The other one they like when they want to try and confuse you is they'll do a kite sort of thing, and again there's 1, 2, 3, 4 sides, so again there's 360 degrees internally. And the same with the pentagon, the sides do not have to be the same. So, alright, let's move on. Triangle inequality, yes. So, I'll talk about this in abstract terms, and I'll talk about where it's very practical for us on the test. In abstract terms, all the triangle inequality says is that the sum of any two sides of a triangle is always greater than the third. So, if you added up A and B, be bigger than C. If you add up B and C, be bigger than A. And if you add up A and C, be bigger than B. Yeah, well and good. The thing to know in practical terms is that if you have any two sides of a triangle, and even if you have some sort of mystery angle here, you can get the third side very quickly. And let me see if I can talk to you about that and give you a sample question. So, if you have 4 and 11 on two sides of a triangle, 11 minus 4 is 7, and 7 here is our lower limit. And then 4 plus 11 is 15, and 15 is our upper limit. This third side forever and always has to be between these two numbers. And importantly, between on the SAT means non-inclusive. So cannot be 7, cannot be 15. Can it be 7 and a million millionths, or 7 and 1 million millionths? And it can be 14.9 repeating forever, not 15. So that's the thing to know. And I'll give you a quick question. So a sample question would be something like, two sides of a triangle are 4 and 11. And it'll ask which one of the following cannot be the third side. And the third side can't be a limit, so it can't be 15. And that would be our answer choice. Sweet. Let's keep on moving. Ah yes, what are integers? Yes. So, integers. One way of thinking about integers is to think of this number line. -3, -2, -1, 0, 1, 2, 3. A lot of people think that integers only include positive numbers. That's problematic. You know, they do. They include negatives. They also include zero. It's another place people trip up. So if you have a box, some people are asking, how many, integers are in this box, or what is the probability of picking an integer from this box? You need to be able to know that 0 and negatives are also integers. It's a very messy 0.5. So that would be 3 out of 4 in this scenario. One way of thinking about them, which I think is very useful, is that they have no decimals or fractions. That's really the only limitation on that situation. But let's keep on moving. Ah yes, prime numbers. Is 1 prime? Is 2 prime? So this is another sort of transaction point where they're going to try and burn you if you're either moving too quickly or not comfortable with these definitions. Prime numbers have exactly 2 positive factors. That is the best definition I've heard out there. There are competing and conflicting definitions, and in fact, there's a little bit of debate about this in the math community. So should you ever want to go visit the Russian anarchist scientists, mathematicians out there, they might give you all sorts of other exotic ideas about prime numbers. But for our purposes and the purpose of the SAT, they have exactly 2 positive factors. And let me see if I can put that into application for you. 13, most people can agree, is prime. Certainly most people who write the SAT are going to make that assertion. 1 is not prime. And because it does not have exactly 2 positive factors, it only has 1 factor. That's exactly what they're going to try and trip you up. So if you have a box and you need to pick out the prime numbers, or the probability of picking a prime number, 1 is not prime. They really like to trick students there. The other place they're going to try and trick you is 2. 2 is the only even prime number. And notice it has exactly 2 positive factors, so it is considered prime in that box. So there are 2 primes in that box. There's still 2 primes in that box. There are now 3 primes in that box. So, good to know. And let's keep moving. Is 0 even? Oh yeah. This is another place they're going to try and burn you. Is it positive, negative, or neither? 0 is considered even. We can get into the logic behind that, but for the purposes of the test, it just is. And I'm not trying to tell you how to think or to what to do, but if everybody says this over here is red, just roll it on the test, right? If you really need to think that it's like red, burgundy, orange, something, just save it for college, right? Like, just get the point, and don't injure yourself in the way with these sort of things. So, all right, is it positive, negative, or neither? That's a little bit more intuitive. It is not. It is neither. It is not considered positive or negative. So let's keep on moving. Ah, yes, Venn diagrams. Let us chat. How do you read a Venn diagram? Venn diagrams are read a particular way, and then we're going to have to complicate that out when we write a Venn diagram. Well, am I doing on time? All right. Here we go. The Venn diagram I've tried to populate here has people who own cats, people who own dogs, people who own cats and dogs, and people who have to be really different. They have to own otters or orangutans or whatever they own. We don't know. So, to get the total population of this chart, you just want to read it at face value. I'm going to talk about these numbers with the line through them in just a moment. But if you see a Venn diagram populated in, please don't modify it at all. Just notice these numbers, 9, 3, 15, and 3. And you're just going to add them up at face value, and that's going to give you total population. Now, let's talk about this another way. If you ever write numbers in, I'll do a quick sketch here. Let's say that there are 50 students taking French, 100 students. Come on back. 100 students. Oh, come on. Technology. 100 students taking Spanish, and 10 students taking both, and then 5 people cheating. They're taking a computer language, like you could in the 90s. Yes. It's very bad Venn diagram. Let's try it over here. So, what I'm going to try to say here is, if you're going to make a Venn diagram for the French, that 50 out here represents the entirety of the circle. So my advice is this: do the both first. Let's go and put 10 in the middle, because if there are 50 in the entirety of the circle, that's going to be 50, put one line through it, and that's 40, who exclusively are taking French. And what's counterintuitive to a lot of students is you're going to do the same thing for Spanish. So if there are 100 students taking Spanish, that 100 represents the entirety of it, 90 are in here, and then the other is pretty straightforward to model. You just keep it outside. Rock. It looks like I'm running out of time for this video, but I do want to say thank you, and please keep on going for the next video. Hello. Thank you for watching. There are 5 easy ways you can help me get the right message out to the right people. Please, you can like, subscribe, and or comment on this video. You can check out my other videos. Please get your question of the day at my website. I just love scribbling on this thing. You can purchase my flashcards at my website. If you've watched this video, you've probably seen some flashcards. They're all available, or at least most of them are available on my website. And you can buy one of my four SAT books on Amazon.com. I do appreciate your time, and I hope this video helps you get where you want to be.